Part 2, here we go. We're going to look at reference angles. They will help us find the trig functions when we have angles that are not matching our special triangles. They're in other quadrants. And thus, that's why we did all that in other quadrants as well. So let's do it by example. I'm going to want to know the sine of 200 degrees. So I have to know what quadrant I'm in. So 0, 90, 180, 270, so it must be in here. So I'm going to draw the hypotenuse, the terminal side of my 200 degree angle. So it starts here and ends here. I'm going to mark it as 200 degrees. Now I'm going to draw the reference triangle that will help me find the sine. And I do that by, again, I've already drawn the terminal side, which is the hypotenuse of my reference triangle, and now I'm just going to raise the side opposite to meet the x-axis. So that is called the reference triangle, and it will always be formed my opposite side connecting to the x-axis. So if this is 200 degrees, how much of the degree is in the actual reference triangle? Well, we can see if we stop here, it's 180, but we go to 200. So the difference between 200 and 180, 20 degrees, is where is the degree in the reference triangle. So I will say at theta reference. So we had theta, the problem was theta is 200, and the reference angle is 20. So now, I don't know the sine of 20 degrees because it's not in my special triangles and it was not on my unit circle either. So I'm going to grab my calculator on these and I'm going to make sure that the mode is in. I hit mode and hit on, hit mode, and it says on mine that I'm in degrees, so make sure you're in degrees. Then I go back and I hit the sine button. And sine of 20. When I hit sine of 20, I get 0.34. So the sine of 20 equals 0.34. And you may say, well, how come you're doing sine of 20 when the problem is sine of 200? It turns out that the trig functions of the reference triangles are the same as the angles. The only difference maybe is the sine. So that's why we had to know what sine, S-I-G-N, the sine, S-I-N-E, of 20 is. So back over here, quick peek, we can see that all students take calculus. So in the third quadrant, sine is a negative value. So we know that the answer is 0.34 with the negative sign. And I'm going to check that. I want you to know how to use reference triangles. And sine of 200, oops, let me start my timer. Enter, negative 0.34. So the calculator knows the sine of 200, but I would like you to use your reference triangles for good practice when calculators aren't allowed or aren't available. So that is an example. Let's do one in radians. Let's say that I want theta is 23 pi over 12. 23 pi over 12 is a radian measure for an angle, and we need to find it first. So let me get rid of this one. We use the same coordinate plane. Alright, so I have to find where it is before I know how to build a reference triangle, what quadrant I'm in. So since this is in 12ths, I can find it fairly quickly because this is pi radians, so that's 1 pi, so that's 12 over 12. And this is 2 pi radians if I go all the way around. So 2 in 12ths would be 24 12ths. And I think that's enough right now. I can see if this is 24 12ths, then 23/12 would start here and go all the way around, almost all the way. So we stop shy, we don't go all the way to 24/12, we stop at 23/12. So that means there must be 1/12 pi over 12 radians inside our reference triangle. So I found the reference triangle is pi over 12. Now I can find the cosine of that. I'm going to try to find the cosine this time of pi over 12 by using that reference triangle and noting that cosine is positive in the fourth quadrant. So looking back at what we just did, all students take calculus. It is positive in the fourth quadrant. We're in the fourth quadrant, so all I have to do is plunk in cosine of pi over 12. This time, however, I'm in radians, so I go back to my mode button, and this time I go over to Radian Measure. Make sure I'm in Radian Measure, and then I clear that and I hit cosine in parentheses pi, it's above the arrow up, divided by 12, close the parentheses, and I got 0.97 basically. 0.97, and I know it's positive because I already investigated that. Alright, we aren't usually going to use reference triangles to find trig functions on these that aren't in our special triangles. So I wanted to show you that that's possible. But I want you to look now at some examples where we're going to use reference triangles and special triangles to get the answers there. See if I have room to see where it says all students take calculus. I'm going to start there and do another example. Alright. And this is what you'll be doing when you come in tomorrow, so take special note. I want you to find sine of 150 without the unit circle, and you could check it with the unit circle, but let's try it with reference angles. As mathematicians, we like to find a lot of different ways to do the same thing. We find that most entertaining. So sine of 150, we're going to try that. We'll try, say, sine of 150, and we want to find the reference triangle. Remember, I put a little r, theta sub r, for the reference triangle. When I find the angle of the reference angle, I will take the sine of that, and hopefully it's in one of my special triangles. Alright, so we have to sketch 150. So 150, we start here, this is 90. If I went all the way over here, it would be 180, but I'm going to stop at 150. So 150 is 30 shy of 180, so it must be 30 in my reference triangle. So the reference angle is 30. So I'm going to take sine of 30, which is in my special triangles. So are they in the screen? They are. So 30 is up here, so I want opposite 30, 1 over hypotenuse 2. Equals 1 over 2. Now I have to check the sine, the SIGN. In the second quadrant, is the sine supposed to be positive or negative? Well, according to the butterfly effect over here, sine is positive. So the answer to sine of 150 is also 1/2. Alright, shall we try another one? Let's try cosine of 4 pi over 3. So turn off the video and try that for a while. What you have to do is sketch it first. So you have to find it. I would recommend doing 8 pi over 6 because we're good at 6 now. So that would be a good way to find it. And then we'll find the reference triangle and use that, the cosine of that, and then check the sine. So turn me off. Alright, you're back. Let's see what you came up with. 4 pi over 3, I recommend it is 8 pi over 6. So when I'm finding that, remember how we divided the top of our unit circle into sixths? I'm going to write in my sixth in the top and my sixth in the bottom. And I'm going to count 8 6 pi. 1 6 pi, 2 6 pi, 3, 4, 5 6 pi, 6, 7, 8 6 pi. It took me right there. So starting here, I went all the way over here. To draw the reference angle, I already have the hypotenuse, that's the terminal side. I'm just going to go up to the x-axis with side opposite, and right there is my reference angle. I notice 2 pieces of pi are inside there, so if they're each a sixth, like I designed them, then they're 2 sixths in there. So that reference angle is going to be 2 6 pi, or pi over 3. So that cosine of 4 pi over the 3 is the same as cosine of pi over 3, which is the reference angle. So the reference angle for this problem is pi over 3. So what about the cosine of pi over 3? Do we know that from our special triangles? Pi over 3 is right here, it's the same as 60. So we want cosine, so we want adjacent over hypotenuse. So we get 1/2. And then we go back and we check in the third quadrant, is cosine negative or positive? It's not in my screen, but it's on your notes. So look in quadrant 3, all students take, so cosine is negative. So I'm going to go back in here and find that the cosine of 4 pi over 3 is negative 1/2. Alright, you've seen one in radians and one in degrees, so I hope that will set you up for success tomorrow. Have a good evening.